Section 11.1 is on permutations and combinations. The fundamental counting principle says that if event M can occur in M number of different ways and is followed by event N that can occur in N number of different ways, then event M followed by event N can occur in M times N ways. Let's take a look at an example. So in California, most license plates are one digit followed by 3 letters, followed by 3 more digits. So how many license plates are possible? So you've got 7 spaces on a typical California license plate. So the first space has to be a digit. And even though we don't see 0, there are actually 10 digits, 0 through 9. So there are 10 possibilities for the first choice, for the first space, followed by 3 letters. And there are 26 letters. I'm sorry about that. And then followed by 3 more digits. Times 10, times 10, and times 10. So there are 10 choices for the first spot, 26 choices for the second, third, and fourth spots, and then 10 choices for the 5th, 6th, and 7th spot. So when you multiply those together, that ends up being 175,760,000 possible license plates. Now, a permutation is an arrangement of items in a particular order. Suppose you have 5 items that you need to put in order. You have 5 choices for the first spot, 4 choices for the second spot, and so on. So using the fundamental counting principle, that would come out to be 5 times 4 times 3 times 2 times 1, which is 120 ways to arrange those 5 items. Using factorial notation, we write this as 5 exclamation point, and we read it as 5 factorial. And just one little side note, by definition, 0 factorial is equal to 1. So here's an example. In how many different ways can you arrange 7 teddy bears on a shelf, one after another? So in the first spot, you have 7 choices of teddy bears, so you place 1 there. Then you have 6 teddy bears left, so you have 6 choices for the second spot, and so on. So this would be 7 factorial, which is equal to 540. Now, how did I know what that was? You can actually do this on your calculator. Let's take a look at that. So you want to go to the math, hit the math button here, and then depending on your calculator, it's either going to be this prob menu or it might be PRB. So we're going to arrow over to that. And you'll see that number 4 here is the exclamation point for factorial. However, you do need to put the number in first. So I'm going to do second mode to quit. I'm going to enter 7, and then I'll do math, over to probability, and then either enter 4 or go down to 4, hit enter, and then enter again, and that gives me 5,040. Sometimes you want to arrange only a certain number of items in a set. So I may have 7 teddy bears, but I only want to arrange 5 of them. Then we're going to use the permutation formula. And that says that the number of permutation of n items of a set arranged r items at a time is written like this. So most of the time it's a subscript n, an uppercase printed p, and followed by a subscript r. And the formula for that is n factorial over the quantity n minus r factorial, where r is a number between 0 and n. So in other words, r cannot be bigger than n. Obviously, because you can't choose more items than you have in the total set. So let's take a look at an example here. In how many different ways can a first, second, and third baseman be selected from 8 players? So we have a total of 8 players. So my n is going to be 8, and I'm choosing a first, second, and third baseman, so my r is 3. So that's going to be 8p3. And using the formula, I'm going to plug in 8 factorial over 8 minus 3 factorial, which gives me 8 factorial over 5 factorial. And remember what that means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Oops. Over 5 times 4 times 3 times 2 times 1. Now that's a little tedious to write, but you'll notice that when I go to simplify this, my 5s, 4s, 3s, 2s, and 1s are going to cancel out. I can actually write this a lot simpler by saying that 8 factorial is equal to 8 times 7 times 6 times 5 factorial, because that's times 4 times 3 times 2 times 1, over 5 factorial. In other words, write your upper number and stop at whatever you have on the bottom. Now those will just cancel out, and I need to do 8 times 7 times 6, which is 333. Okay? Sometimes the particular order of the selected items does not matter, so it doesn't matter which teddy bear goes in the first spot. Then we're going to use the combination formula, which says the number of combinations of n items of a set chosen r items at a time is this formula here. So subscript n, uppercase C, subscript r, which is n factorial over r factorial times the quantity n minus r factorial. Notice this is very similar to the permutation formula, but it adds this, oops, sorry about that, adds this r factorial here at the bottom. And again, n has to be greater than r. So here's an example. In how many different ways can the principal choose 5 students from a group of 15 to serve on a committee? So the total number of students is 15, and the principal is going to be choosing 5 of them. So that's going to be 15 C5. So that's plugging these numbers into the formula, 15 factorial over 5 factorial times 15 minus 5 factorial, over 15 factorial, oops, over 5 factorial times 10 factorial. Now you cannot multiply the 5 factorial and the 10 factorial to get 50 factorial or 15 or anything like that. So I'm going to take my number on top, 15, and I'm going to write that, 15 factorial, and write that and stop at 10 factorial, because that's my bigger one on the bottom. And then I'll have 5 times 4 times 3 times 2 times 1, which isn't too bad to deal with, times 10 factorial. Now when I go to simplify this, those will cancel out, and my product on the top is 360 over 120, or 3,003 ways that the principal can choose 5 students out of 15 to serve on a committee. Now sometimes you need to actually decide whether or not you're going to use a permutation or a combination. Remember, for a permutation the order matters. For a combination, the order does not matter. So this example says, for each situation, determine whether you should use a permutation or a combination, and then answer the question. First one, you have 20 songs on your phone. I know that's not a lot of songs, but let's say you only have 20 songs on your phone. And how many ways can you select 4 songs to listen to? Does this say anything about the order? No, it doesn't. You're just going to listen to 4 songs in any particular order out of the 20 that you have. So this is going to be a combination. I don't know why the pen is kind of slow there. And I have 20 total songs, and it's a combination, and I'm going to choose 4. Now, instead of writing all this out, as you probably know, you can do this on your calculator. So let's go ahead and take a look at how to do this on the calculator. So again, I'm going to go to the Math menu, and I'm going to go over to Probability. Oops, I went one too far. Okay, and here you'll see number 3 is NCR, so I'm going to go down to that one. And depending on your calculator, you might actually have to put the N in first. I don't. My calculator actually has a little box down here. So I can put 20 in there and just arrow over till I get to the other box, put in a 4, and this does the calculations for me. So there are 4,845 ways that I can choose 4 songs out of a list of 20. Okay, last example here. In how many different ways can the first, second, and third place winners of an art competition be chosen from 15 participants? Because there has to be a first place winner, a second place winner, and a third place winner, the order does matter. So this is going to be a permutation. Not sure why the pen is a little slow. Anyway, so this is going to be 15p3. And again, I'll go to my calculator, go back to the math menu, go over to probability, one more, and down to NPR, hit enter, and I have 15, arrow over, and then I'm going to choose 3 of them, and then hit enter, and that should give me 2,730. So there are 2,730 ways that I can choose a first, second, and third place winner from an art competition that has 15 participants. So in this section we took a look at permutations and combinations, when to use each, and how to do it by hand, and how to do it with a calculator.